When no hazard evaluation has been performed, it is correct to assume that Table 3-3.91 and 3-3.92 of National Fire Protection Association 70E should be followed for selecting appropriate personal protective equipment. These tables offer minimum personal protective equipment requirements based on voltage and arc flash boundary. A company's training that instructs employees to follow equipment installation manuals may not fully protect them from liability, especially if it does not adequately address the requirements of National Fire Protection Association 70E. While equipment manuals may provide specific instructions for the task being performed, they may not fully address the electrical hazards present, such as arc flash hazards. National Fire Protection Association 70E is a comprehensive standard that provides guidance on electrical safety, including hazard assessment and personal protective equipment selection. National Fire Protection Association 70E does provide an exception for certain low-voltage applications in data centers where the installation of a circuit breaker does not require shutdown of the circuit. This exception allows for the use of reduced personal protective equipment, as specified in Table 3-3.938 and 3-3.94a. To ensure compliance with National Fire Protection Association 70E and minimize risks, firstly, conduct a comprehensive hazard evaluation to determine the actual arc flash hazards present. Secondly, train employees on National Fire Protection Association 70E requirements and the specific procedures for electrical work in the data center. Thirdly, verify that equipment installation manuals address arc flash hazards and proper personal protective equipment. Fourthly, consider using non-shutdown techniques such as using a glove bag or touch probe when installing breakers in live circuits. Fifthly, follow established safety procedures and where appropriate personal protective equipment is determined by the hazard evaluation. It is important to understand the nuances of National Fire Protection Association 70E, especially when working in environments like data centers where maintaining uptime is critical but worker safety remains paramount. A hazard evaluation is a systematic process to identify and analyze potential hazards associated with a specific task or environment. In the context of electrical safety, it involves assessing the risks of electric shock, arc flash, and arc blast. The evaluation should consider factors such as voltage levels, fault current availability, working distance, and the presence of conductive materials. The results of the hazard evaluation will determine the appropriate personal protective equipment and safe work practices necessary to mitigate the identified risks. National Fire Protection Association 70E provides detailed guidance on how to conduct a hazard evaluation, including the use of tables and calculations to estimate arc flash incident energy. Incident energy is the amount of thermal energy generated during an arc flash event, measured in calories per square centimeter. This value is used to select personal protective equipment with an appropriate arc rating, which indicates the level of protection the equipment provides against thermal hazards. Personal protective equipment is essential for protecting workers from electrical hazards. National Fire Protection Association 70E specifies the minimum personal protective equipment requirements based on the potential exposure to arc flash hazards. This equipment includes, but is not limited to, flame-resistant clothing, arc-rated face shields or hoods, safety glasses, insulated gloves, and footwear. The selection of personal protective equipment must be based on the incident energy calculated during the hazard evaluation. Flame-resistant clothing is designed to resist ignition and prevent the spread of flames. It is typically made from materials such as treated cotton, Nomex, or other inherently flame-resistant fibers. The clothing should cover as much of the body as possible, including the arms, legs, and torso. Arc-rated face shields or hoods provide protection to the face and head from arc flash hazards. They are made from materials that can withstand high levels of thermal energy. Safety glasses should be worn under the face shield or hood to protect the eyes from flying debris. Insulated gloves are used to protect the hands from electric shock. They are made from rubber or other insulating materials and are rated for specific voltage levels. The gloves should be inspected before each use for any signs of damage. Footwear should be non-conductive and provide protection from electrical hazards. It is important to ensure that the footwear is in good condition and free from any defects. Training is a critical component of any electrical safety program. Employees must be trained on the hazards associated with electrical work, the requirements of National Fire Protection Association 70E, and the proper use of personal protective equipment. The training should be specific to the tasks and environments in which the employees will be working. It should also be updated regularly to reflect changes in technology, regulations, and best practices. The training program should cover topics such as hazard evaluation, arc flash protection, lockout/tagout procedures, and safe work practices. Employees should also be trained on how to respond to electrical emergencies such as electric shock or arc flash incident. Data centers present unique challenges for electrical safety. These facilities typically have a high concentration of electrical equipment and a critical need for uptime. As a result, there may be pressure to perform electrical work on energized equipment, which increases the risk of electrical hazards. National Fire Protection Association 70 recognizes the unique challenges of data centers and provides an exception for certain low-voltage applications where the installation of a circuit breaker does not require shutdown of the circuit. This exception is based on the assumption that the risk of an arc flash event is lower in these situations. However, it is important to note that this exception should only be applied when a thorough hazard evaluation has been performed and it has been determined that the risk of an arc flash event is acceptable. Even when this exception is applied, it is still necessary to use appropriate personal protective equipment and follow safe work practices. Non-shutdown techniques, such as using a glove bag or touch probe, can be used to install breakers in live circuits. A glove bag is a temporary enclosure that provides a safe working environment for performing electrical work on energized equipment. The bag is made from insulating material and has gloves attached to it, allowing the worker to manipulate the equipment inside the bag without being exposed to electrical hazards. A touch probe is a device used to measure voltage levels without making direct contact with the energized equipment. This can be useful for troubleshooting electrical problems or verifying that a circuit is de-energized before working on it. It is important to follow established safety procedures and wear appropriate personal protective equipment when using non-shutdown techniques. Safe work practices are essential for preventing electrical accidents. These practices include, but are not limited to, de-energizing equipment before working on it, using lockout/tagout procedures, maintaining a safe working distance from energized equipment, and using insulated tools. Lockout/tagout procedures are used to ensure that equipment is de-energized and cannot be accidentally energized while work is being performed. These procedures involve placing a lock and tag on the equipment's power source to prevent it from being turned on. A safe working distance is the minimum distance that a worker should maintain from energized equipment. This distance is based on the voltage level of the equipment and the potential for an arc flash event. Insulated tools are used to protect workers from electric shock. These tools are made from non-conductive materials and are designed to prevent electricity from flowing through the worker's body. In conclusion, electrical safety is a critical concern for anyone working with or around electrical equipment. National Fire Protection Association 70E provides comprehensive guidance on how to protect workers from electrical hazards. It is important to conduct a thorough hazard evaluation, use appropriate personal protective equipment, follow safe work practices, and provide adequate training to employees. By following these guidelines, it is possible to minimize the risk of electrical accidents and ensure the safety of workers. Remember that even in situations where exceptions may apply, such as in data centers with specific low-voltage installations, a rigorous assessment of potential hazards must always be prioritized. This includes a careful evaluation of the equipment installation manuals in relation to the specific requirements outlined in National Fire Protection Association 70E. Ensuring the manuals adequately address arc flash hazards and provide guidance on proper personal protective equipment is crucial. The goal is to create a layered approach to safety, combining the manufacturer's instructions with the overarching safety standards to achieve a secure working environment. Furthermore, the company's responsibility extends beyond simply providing training and equipment. It includes fostering a safety culture where employees feel empowered to identify potential hazards and report concerns without fear of reprisal. Regular safety audits and inspections should be conducted to identify areas for improvement and ensure that safety procedures are being followed consistently. Continuous improvement is essential to maintaining a high level of electrical safety. By staying informed about the latest technologies, regulations, and best practices, companies can adapt their safety programs to meet the evolving challenges of the electrical industry. This proactive approach not only protects workers from harm, but also reduces the risk of costly downtime and equipment damage. Ultimately, the goal of electrical safety is to create a work environment where everyone can perform their tasks safely and efficiently. By prioritizing safety and investing in the necessary resources, companies can demonstrate their commitment to protecting their most valuable asset, their employees. The specific recommendations provided, such as conducting hazard evaluations, training employees, verifying equipment manuals, considering non-shutdown techniques, and following established safety procedures, are not merely suggestions but essential steps in mitigating electrical risks. Ignoring these recommendations can lead to serious injuries or even fatalities. Therefore, it is imperative that all stakeholders, including employers, employees, and safety professionals, work together to create a culture of safety that prioritizes the well-being of workers. One should remember the importance of clear communication. Safety procedures and hazard information should be communicated effectively to all employees in a language they understand. This may involve providing training materials in multiple languages or using visual aids to illustrate key concepts. Additionally, employees should be encouraged to ask questions and seek clarification whenever they are unsure about a safety procedure or potential hazard. By fostering open communication, companies can create a more informed and engaged workforce, which is essential for maintaining a high level of safety. Remember that electrical safety is not a one-time effort, but an ongoing process. It requires continuous vigilance, training, and improvement. By committing to these principles, companies can create a safer and more productive work environment for everyone. If working with three-phase power, it's essential to understand the voltage levels and configurations commonly used. For example, 208 volts is often used in commercial buildings and is derived from a three-phase system. Similarly, 480 volts is another common voltage level used in industrial settings. Understanding the voltage levels and configurations is crucial for selecting the appropriate personal protective equipment and safe work practices. In addition to voltage levels, it's also important to understand the concept of fault current. Fault current is the amount of current that flows through a circuit during a short circuit or ground fault. The higher the fault current, the greater the potential for an arc flash event. Therefore, it's essential to calculate the fault current at each location where electrical work is being performed. This information can be used to select the appropriate overcurrent protection devices, such as circuit breakers and fuses, to limit the fault current and reduce the risk of an arc flash event. Remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By working together and following established safety procedures, we can create a safer and more productive work environment for everyone. A key aspect of electrical safety is the proper use of test equipment. Multimeters, clamp meters, and other test instruments are essential tools for troubleshooting electrical problems and verifying that circuits are energized before working on them. However, it's important to use these instruments correctly and safely. Before using any test equipment, be sure to read the manufacturer's instructions and understand how to use the instrument properly. Always use the appropriate probes and leads for the voltage and current levels being measured. Never use test equipment that is damaged or defective. And always wear appropriate personal protective equipment when using test equipment. Another important aspect of electrical safety is the proper grounding of electrical systems. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. This helps to prevent electric shock and reduce the risk of fire. All electrical equipment should be properly grounded in accordance with the National Electrical Code. This includes grounding the metal enclosures of electrical equipment, grounding the neutral conductor of electrical systems, and grounding the equipment grounding conductors. The National Electrical Code, or National Fire Protection Association 70, is a widely adopted standard for electrical safety in the United States. It provides detailed requirements for the installation and maintenance of electrical systems. It's essential for anyone working with or around electrical equipment to be familiar with the National Electrical Code and to follow its requirements. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. Therefore, it's important to stay up to date with the latest edition of the National Electrical Code. Arc flash studies are a valuable tool for assessing the potential hazards of arc flash events. An arc flash study is a detailed analysis of an electrical system to determine the incident energy levels at various locations. This information can be used to select the appropriate personal protective equipment and to develop safe work practices. Arc flash studies should be performed by qualified professionals using specialized software and equipment. The results of the arc flash study should be documented and made available to all employees who work on or around electrical equipment. Electrical safety audits are another important tool for ensuring compliance with safety regulations. An electrical safety audit is a systematic review of an electrical system to identify potential hazards and to verify that safety procedures are being followed. Electrical safety audits should be performed by qualified professionals on a regular basis. The results of the audit should be documented and used to develop corrective action plans to address any identified deficiencies. Remember that electrical safety is an ongoing process. It requires continuous vigilance, training, and improvement. By committing to these principles, we can create a safer and more productive work environment for everyone. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before performing any electrical work. Working on electrical systems can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. Following safety procedures, wearing appropriate personal protective equipment, and using the right tools and equipment are essential for preventing electrical accidents. Remember that safety is always the top priority. Never take shortcuts or compromise safety for the sake of speed or convenience. By working safely and following established procedures, we can all help to prevent electrical accidents and create a safer work environment. The tables in National Fire Protection Association 70E, such as 3-3.91, 3-3.92, 3-3.93A, and 3-3.94A, provide specific guidance on selecting personal protective equipment based on the potential arc flash hazard. These tables should be used in conjunction with a hazard evaluation to determine the appropriate level of protection. It's important to understand the different categories of personal protective equipment and to select the equipment that provides the necessary level of protection. For example, arc-rated clothing is available in different arc thermal performance value ratings, which indicate the level of protection the clothing provides against thermal energy. The arc thermal performance value rating should be selected based on the incident energy calculated during the hazard evaluation. In addition to arc-rated clothing, other personal protective equipment items such as face shields, gloves, and footwear should also be selected based on the potential arc flash hazard. The face shield should provide adequate protection for the face and eyes, while the gloves should be rated for the voltage level being worked on. The footwear should be non-conductive and provide protection from electrical hazards. Remember that personal protective equipment is the last line of defense against electrical hazards. It's important to use personal protective equipment correctly and to inspect it regularly for any signs of damage. Damaged or defective personal protective equipment should be replaced immediately. While personal protective equipment is essential for protecting workers from electrical hazards, it's also important to implement other safety measures, such as de-energizing equipment before working on it, using lockout/tagout procedures, and maintaining a safe working distance from energized equipment. These measures can help to reduce the risk of electrical accidents and create a safer work environment. The specific recommendations provided, such as conducting hazard evaluations, training employees, verifying equipment manuals, considering non-shutdown techniques, and following established safety procedures, are not merely suggestions but essential steps in mitigating electrical risks. Ignoring these recommendations can lead to serious injuries or even fatalities. Therefore, it's imperative that all stakeholders, including employers, employees, and safety professionals, work together to create a culture of safety that prioritizes the well-being of workers. In the context of data centers, where uptime is critical, it's important to carefully consider the risks and benefits of performing electrical work on energized equipment. While non-shutdown techniques can be used to minimize downtime, they also increase the risk of electrical accidents. Therefore, it's essential to conduct a thorough hazard evaluation and to implement appropriate safety measures before performing any electrical work on energized equipment. These measures may include using insulated tools, wearing appropriate personal protective equipment, and maintaining a safe working distance from energized equipment. It's also important to have a plan in place for responding to electrical emergencies, such as electric shock or arc flash incidents. This plan should include procedures for providing first aid, contacting emergency services, and investigating the incident. By having a well-defined emergency response plan, companies can minimize the impact of electrical accidents and ensure the safety of their workers. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before performing any electrical work. Working on electrical systems can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. Remember that safety is always the top priority. Never take shortcuts or compromise safety for the sake of speed or convenience. By working safely and following established procedures, we can all help to prevent electrical accidents and create a safer work environment. Remember also that it is important to stay current on changes and updates to the National Electric Code, National Fire Protection Association 70E, and other applicable standards and regulations. These resources offer the most current and vetted safety procedures for your protection.